Okay, so we're going to have a look at question number 3. So we're given some information about a Venn diagram. It doesn't tell us anything about whether these events are independent or mutually exclusive, so I'm going to use a standard Venn diagram, and we should be able to see that we've got 4 regions, 1, 2, 3, 4. I'm going to give them letters to signify the different regions, J, K, L, and M. You can choose whatever letters you want. Now I know that the probability of A is 0.45, so that's this entire circle here, so I can say J plus K equals 0.45. A intersection B dash, that means it is in A, so it is in this circle, but it's not in B, so it can't include K, so this is just J alone, is 0.25. And A union B, so it's either an A or B or both, J plus K plus L equals 0.8. So it's actually given us significantly easier information than it can do. So I'm going to start by using this value here. I've got J equals 0.25, so let's just tick that off. So I can put my 0.25 here. J plus K equals 0.45, so this must be 0.2. And J plus K plus L, well, I've got 0.45 between those two, plus L equals 0.8, so this must be 0.35. If these regions add up to 0.8, it means that the outside region must be 0.2. So we're now going to move on to part B, which are conditional probability questions. So if we have a look at the first one, I'm looking at the probability of A given B dash. So we're going to do that by restricting the domain. So I'm going to look at the denominator first. The denominator tells me that it's not B, so it's everything outside of this circle. So I've got the denominator is going to be 0.25 plus 0.2, which is 0.45. Out of that, I've already excluded those two bits here, and I'm just left with my 0.25 and 0.2. Out of that, I'm only interested in the bit which is in A, which is 0.25. So it's 0.25 out of 0.45, which is going to give me 5 out of 9. I'm going to do part 2 in a similar way. My denominator tells me I'm not in A, so I've got to be outside of this circle here. I'm not in A, so the denominator is going to be these two regions here, 0.35 and 0.2, which is 0.45. Sorry, 0.55. Out of that, I'm looking at the bit which is not in B. The bit which is not in B is just this bit here, which is 0.2 out of 0.55, which gives me 4 out of 11. Okay, we're going to go on to part C, which is somewhat more complicated. Let's firstly look at what my denominator is. If I look at A dash union B dash, well, here I've got A and B, so A dash is everything outside A, and B dash is everything which is outside of B. So I'm looking for everything which has been shaded at least once. So the bit which has been shaded at least once, I'm just going to redraw that here. The bit which has been shaded at least once is everything apart from that intersection here. So everything apart from the region K. So that means my denominator must be out of 0.8. I'm then looking at A intersection B dash. Let's just have a quick look at what that looks like. So B dash is everything outside B, which I'm going to shade in blue. It's everything outside B. It's A intersection B dash, so it's going to have to be looking at A. The intersection is the bit which has been shaded twice. The bit which has been shaded twice, I'll redraw it here. the bit which has been shaded twice is going to be just this bit here. That's A intersection B dash. So I'm looking at my numerator then is going to be this bit, 0.25. 0.25 out of 0.8, which is going to give me an answer of 5 out of 16.